Okay, this is Math 2, 57 to 60, in Chapter 10. Marty saved $3,000, has saved $3,000, and divided among 3 investments, see how his money grows over time. Why are we still doing these problems? We already know what the pun is. The table below shows his earnings over 6 months. Describe the growth of each investment. They're making money. Okay. That's the end of the description. Oh my goodness. Let's see. Each investment. Okay. Well, all of them are making money. So yes, there's growth. Description. Okay. Well, this is probably going to be your linear because it looks like you're adding 10 every time. Yay. Plus 10, plus 10, plus 10, plus 10. Okay, so this is your linear one. This looks like it's exponential, and you're multiplying by, I'm going to guess 1.1. See, 10 divided by 1,000? Yep, 1.01. Oh, I was off by, okay. So it looks like you're multiplying each time by 1.01, so this is your exponential. And then investment C, if it's not linear and it's not exponential, you only have a couple of options available. Not growing at all, but obviously it is. So this must be the quadratic. How is it growing though? There's your month, so these are like your X's. So this is 1,000 plus x squared. Yeah, 1 squared is 1. 1 plus 1,000 is just 1,001. So 1,000 plus x squared again. So 2 squared. So 1,000 plus 4, that's 1,000 plus 4, or 2 squared, and then it keeps going. Yep, this is definitely quadratic. Okay, next one. Calculate the average rate of change of each investment from month 4 to month 6. So this was how much did we grow and how much time has passed. So for month 4, for investment A, we grew by 20, so, or 1060 minus 1040, and so we had a growth of $20, right? Yep. And then it was over the course of 2 months, or 6 minus 4, over 2 months, sorry. So, so for investment A, we grew $20 in 2 months, so basically went up $10 each month. Okay, which makes sense because it's linear. Investment B, from 4 to 6, we went, let's see, 1061.50 minus 140.6. We went $20.09 over the course of 2 months. So divided by 2, we basically went up $10.45 in that, over 1 month's actual time span. And then part C, we went from 16 to 36. So 36 minus 16, 20 over the course of 2 months. And then, so that's basically $10 a month again also. So which one, assume each investment continues to grow in the same way it has grown during the first 6 months. If Marty plans to invest money, which investment is the best choice? Exponential, because exponential always is going to grow the fastest. Exponential, or better known as investment B, since it's exponential, grows much faster, as you could tell, because obviously by the 6th month, investment B is much higher than the other two. Okay, next one. Solve the equations below for x. You guys should know how to do these on your own by now. If you don't like the fraction, turn it into a decimal. B shouldn't be a problem. For C, the only thing I can remind you is please make sure you put parentheses around the 4x minus 1, around the x plus 5. And you can start this off and put the put the number that you're distributing out in front. Okay, and then the last one is a quadratic. Please use a quadratic because I don't think you're going to find any numbers to multiply out to 6 that add up to -4. So A equals 1, B is going to be -4, C is going to be a 6, and work it out. You should get, I'm telling you right now, you should get an answer where you're going to have to put it in terms of I, because you will get a negative underneath the radical sign. I can tell you that right now. All right, so 58 should be easy to do. And then 59. Are we in the last one? No. We're not in the last one. 59. Okay. Bunnies. Oh, he's so cute. I'm going to color them in. Look at the bunny. He's got orange fur. Yay. Oh, they're so cute. I just want to take one home. All right. What does it say? Welded wire fencing is sold in rolls of 100 linear feet. This is actually not true. Does anyone know? Is actually welded wire fencing sold in 100 rolls of 100 linear feet? I feel like I want to go to Home Depot and see if this is true or not. The farmer builds a rectangular rabbit pen, which makes things very easy for us, using exactly 1 roll of wire. Okay, so we know we have 100 linear feet to work with. The length of the pen is 2 feet less than 3 times its width, and the area of the pen is 481 square feet. What? Draw a diagram of the pen and label its dimensions. Okay, I think we could handle this. Okay, so it's a rectangular pen, or a rectangular cage. We should probably use cage. And we know we have 100 linear feet. So if you add up all the sides of it, it's going to be 100. So this is going to be our perimeter. Okay. Draw a diagram of the pen and label its dimensions. Okay, the length is what? The length of the pen is 2 feet less than 3 times its width. Okay, well, I don't know. I guess we can just say W and then work off that one. That should be okay. So this is the width, right? This is the width. The length is equal to 2 feet less than 3 times the width. So 3 times the width minus 2. Okay, so the length up here is 3W minus 2. The length is. Okay, write 2 equations to determine the dimensions of the pen, one using the area and one using the perimeter. Okay, we can do this pretty easy. So the perimeter is adding up all the sides. So we have W plus L plus L. But we know what L is. L is 3 times the width minus 2. So W plus L is 3W minus 2 plus 3W minus 2. Okay, so how many W's we have? 1, 2, and then 3 and 3, so that's 6, 7, 8. So 8W minus 2, so minus 4 is the perimeter. But we have 100 linear feet of fencing to use, so technically the perimeter is 100. So we say plus 4, so 104 equals 8W divided by 8. I don't know, no idea what 104 is divided by 8. Matt, what's 104 divided by 8? I don't have a calculator. I just don't have it near me. I don't know where it's at. 13. Okay, good. So W is equal to 13. Or the width is 13. And then that's finding using the perimeter. Okay, we got to plug it back in and actually find the length. So if the width is 13, that's 13. The length is 3 times 13 minus 2. So 3 times 13, 39 minus 2. So the length is 37. Yay. 37 what? Feet. Okay, here we go. 13 feet is the width, 37 feet is the width. I mean the length. Okay, so that pretty much takes care of part C because we wanted the dimensions of the pen. But it does say to write two equations to determine dimensions of the pen, one using the area and one using the perimeter. We only did the perimeter one, which is, okay, fine. If you wanted to use the area one, area is just length times the width. So area is length times the width. The length is 3w minus 2. The width is just w. The area is 481 feet, because it actually said that in the problem all the way back at the top. Okay, so you have w times 3w, w times negative 2, so 3w squared, and minus 2w equals 481. That's a quadratic, because it's w squared. So you have 0 equals 3w squared minus 2w minus 481. And, oh boy. In order to solve this, a equals 3, b equals negative 2, c equals negative 481. And if you did all this work and punched it in, you should get x equals 13 and something else. I don't even know what the other something else is, but you're probably going to get something here that's a negative number, which pretty much should not make sense in the context of the problem because you can't have a negative width on something. So x equals 13 is your only option. Please work this out because you need more practice actually working the quadratic formula out. And then when you plug it back in again, you should get 37 feet for the length. Okay, so that was number 59. And then lastly is 60. We're writing a flow chart. Oh boy. Okay, so hold on a second. So what's the givens? If point M is the midpoint of Q to K, or KQ, okay, so that means these are the same. Okay, so those are givens because it tells us that in the problem. M is the midpoint. Actually, that's not the given. Given's going to be just M is the midpoint. And if angle L is congruent to angle, prove that KL is congruent to QP. All right, so let's see what we have. What is this going to be congruent by anyways? So those are going to be same. These are angles. Oh, here it is. Okay, so we're going to put these down. M is given. These are not given. So these are your vertical angles. Okay, so let's see what we have. We have angle, angle, side. Okay, so at least I know it's going to be angle, angle, side. I should probably do this bubble bigger. Okay, so what do we have? M is the midpoint. And that means, this is the given, that means KM and QM are equal. So KM is congruent to QM, definition of midpoint. And what do we have? We have L and P. Angle L is congruent to angle P. This is a given in the problem. There's nothing else after that. That's pretty much a standard. And then lastly, we have these two. So angle KML is congruent to angle QMP, vertical angles. And that's pretty much it. Definition of midpoint, given. That one's given. So angle, angle, side. So triangle, what is going to be congruent to triangle what? That's pretty much it. Okay, that takes care of that. I will see you guys later in the next video.